Okay, polynomial functions. Right, now that there looks a little more complicated than it actually is. Okay, we have here x's with descending order of exponents. We have a coefficient in front of the x. Okay, it could be an integer, it could be a fraction, it could be a negative. Let's have a look at some examples. Okay, so the constant, okay, 3. We can think of this as 3x to the power 0, okay, because anything to the power 0 is 1. It's still 3. Well, that means it's degree 0, okay? That's the highest exponent, 0, okay? The leading term is just 3. The leading coefficient is just 3. Let's have a look at some bit more complicated ones. Okay, can you see this would have a 1 there, so its degree is 1. Its leading term is 2/3 x. And the leading coefficient is the 2/3. So this looks like it's going to be degree 2. It's an x squared. Degree 2. The leading term is 4x squared. The leading coefficient is the 4. An x cubed. So it's degree 3. Looks like its leading term is just the x cubed. So its leading coefficient is just 1. Imagine there's a 1 there. And lastly, this is going to be degree 4. There it is. Leading term is negative x to the 4th. So the leading coefficient is negative 1. Think of that as negative 1. Okay? Right, just examples of polynomials. Right, the quadratics. Okay, if I have a quadratic function like this, if I factor it, I'll get this. This is just old news, okay? Factor it, get this. So the zeros are negative 1 and positive 3. What makes it 0? These are therefore the x-intercepts. There's the negative 1 and the positive 3. It's got a minimum negative 4 at x equals 1. The reason for that is, do you remember this? Negative b over 2a. Okay, what's negative b over 2a? So negative 2 over 2 lots of 1, so negative 2, over 2 lots of 1. That's positive 2 over 2. There it is. X is 1. Okay, that's where the minimum occurs. What the minimum actually is me putting 1 back into the equation, here and here. What's 1 squared? 1. Take away 2 lots of 1. So 1 take away 2, and then take away 3 will give me negative 4. Okay, remember that from previous videos. It doesn't have a maximum, it's got a minimum. And the domain, right, domain of quadratics, look at it, negative infinity to positive infinity. It's going all the way to the left, all the way to the right. That's domains. The range is negative 4, okay, the minimum y, maximum y, it's going up to infinity, both ways, okay? So that's the range. Let's have a look at a trinomial, the cubic one. Sorry, not a trinomial, cubic. Right, okay, so again, if I have this as an equation and it factors to this, more on that later, then again I'll have zeros of negative 4, negative 1, positive 3. There they are. So that's where the x-intercepts are. Negative 4, negative 1, and positive 3. The y-intercept, right, the y-intercept, I should have mentioned that earlier. Look at this, the y-intercept here is negative 3. I totally missed that one. There it is, okay? So there's the y-intercept. Down here, the y-intercept is at negative 12. There it is. Where is it? Well, it's hard to see. There's the scale, okay? It's just that right there, when x is 0. Okay, the minimum. Well, that is for you to actually, that's not for this right now, okay? Calculations there, okay? It's just showing it on the graph. The domain, negative infinity to positive infinity, and the range, again, negative infinity to positive infinity. Okay, so that's just you looking at the quadratics and the cubics. Kind of graphing, we've done some of that before. Right, what else do we have? Right, non-polynomials. Now look, it says here, read this. Probably noted that the graph of a polynomial is continuous, no holes, it's smooth, no sharp corners. The domain is the set of all real numbers. Right, again, look at these two polynomials. Okay, smooth, continuous, domain, all real numbers. So these are not, that's got a sharp part to it, okay? This doesn't go to negative infinity, another sharp part. This has a break in it, okay? So these aren't polynomials. Again, nice polynomial, not. Alright? Okay, the leading term test. Now this is just you looking at a polynomial and deciding what happens as x goes to infinity and x goes to negative infinity. What happens at the ends of these graphs, okay? So, that's what it means by x becoming very small. Are we going on the number line to the minus, okay, negative infinity, or to positive infinity? X becomes very large. Let's have a look. Okay, even degree. Here's an x squared graph. Can you see as x is going to positive infinity, I've got to go this way, I'm back to front, positive infinity, it's going up. To negative infinity, it's also going up. This is a positive x squared. They're both going up as the graph goes that way. Okay? A negative x to the fourth. Okay, so this is a negative even degree. These are both going down as the graph goes to the left and the right. Okay? Again, another positive even, just like this one. Positive even. Positive even. Look, both going up as they go to the left and the right. Okay, so this one was positive. This one was positive. This one's a negative. This one here, negative x to the 10th, negative. Can you see they're both going down? Even degrees. Odd degrees, a positive one, rises to the right. Okay, it's going up that way as x goes to infinity. And it goes down as it goes to the left, to negative infinity. Okay, that's a positive one. Look at the negative odd. Where is it? There you go, negative. Okay, this one's going the opposite way. Okay, so again, I'm kind of back to front here. It's rising to the left, okay, and falling to the right. Okay, again, this one looks very similar here because it's another negative odd degree. Okay, a positive odd degree, again, looks like the first one, rising to the right, falling to the left. Okay, as we go to positive infinity and negative infinity. So that's just recognizing what they might look like, the end behavior, okay, of graphs. Let's keep on going, try some of these. So there it is, there's the summary, okay. So positive one rises to the left and rises to the right, okay. An odd degree will rise to the right and fall to the left. So as x goes to infinity, okay, it rises. As x goes to negative infinity, it falls. And for negatives, it's the opposite way around, okay? A negative even degree looks both falling, okay? And then negative odd degree, this one is rising to the left. You're going to have to do opposite to the left, falling to the right, okay? Okay, let's have a look at some examples. And here we go. Okay, right, just look at that. Positive, even degree, must be that one. Remember the rules? You can go back, have a quick look at this, okay? So that's, there it is. Right, B is a negative odd degree. Negative odd degrees do this. Okay, remember, rise to the left, fall to the right. So that's B, there it is. Okay. Positive odd degree, well that's that one. There you go. And finally, it's like a negative even falling to the right and left. Okay, there you go.